Ratios. Hey, good day, YouTubes. Reset the hummingbird feeder outside, one of the two. Washed in fresh nectar in there, so sugar and water, right? What animal doesn't like that? So, ratios. This is something that's kind of easy to understand, but hard to understand. So, here goes. A lot of measurements provide different ways to look at them, different perspectives, different, what's the word I'm looking for? They have a different something. I lost it. Do you hate when you lose words? Concept. That's what I was looking for. It was there. So some of these things are just concepts. A ratio is a concept. If you have 2 bananas and 1 apple, you have a ratio of 2 to 3. If you get 2/3 of a cup of water, you have 1/3 of a cup of air. So that concept, that idea of ratios is very important if you're building a bridge. You know, the ratio of cars over time versus wearing the bridge out, and density of traffic, how congested is it. So these ratios are all around us, and you just don't think about it. Sometimes you don't have to. But in the sciences, these ratios begin to become apparent and important. H2O is a ratio of 2 hydrogen atoms to 1 oxygen atom. In order to make H2O, water, you would have to have 2 hydrogens for every 1 oxygen in a perfect burn. So those little ratios are forced in places. They're just part of the equation. They're knowns. Now, nuclear science is where this comes in. We've learned how to easily identify isotopes. This is past elements. This is isotopes, the periodic table of isotopes. So we talk about cesium in different numbers. We talk about uranium in different numbers, plutonium in different numbers. You get into the 248s and you talk about decay properties. So these ratio things begin to just become a part of the knowledge of what is related to another thing. Now the bananas and apple is kind of, unless you're making fruit salad, now you know your fruit salad has, so on the label you put bananas first and apples second. Unless it's a huge apple and outweighs the bananas, then you do list. So yeah, but identifying isotopes with decay properties has become the thing. We know how slowly many elements decay, and by measuring the ratio of one decay to another, you can begin to tell time. You can begin to tell locations, because some of these things formed minutely differently. It's the signature from Fukushima is a ratio of, should be uranium isotopes according to some of the propaganda, but it is many isotopes. There is plutonium, there is iodine, there is deuterium. There are all these related components, and their ratios are still being studied, but reasonably understood. This is how we date things. We no longer use carbon dating for a lot of date analysis because we have found much more precise ways to do it, much lower margins of error to do it. So on the good side, good news, maybe The IAEA has declared themselves part of the Open Society and are beginning to publish and share documents online from their archives. So they've been moving them from microfiche into digital electronic formats. Now, this information comes from a lot of universities, a lot of government organizations, a lot of corporations supplying information about their business because they have to. So there's going to be massive amounts of reading available in that one. Good luck. It's much harder than the Bible to interpret. Take a look. It'll scare you. Halloween's over, sorry. Anyway, good day. I've retired the coffee. Past that, got a soda sitting here I haven't opened. Should put it away and go drink water. Peace out.